Hello, boys and girls of class 504 and 501. This is Mr. Mendoza back for another video. And today we're going to be calculating the volume of composite figures. Before I start, you should be, right now, you should have the PowerPoint open and my video opened on another tab. So that when we get to the guiding questions, you can pause the video, answer the question on the PowerPoint, and then jump right back to the video. Okay, we're ready. So I'm going to read the problem. Find the volume of the building. Calculate the volume of each building part, then add the volumes of the two parts together. So we're calculating the volume for what's called a composite figure. Well, what is a composite figure? A composite figure is a figure that can be separated into two normal figures. So we can separate this one figure into two rectangular prisms, something that we can use this volume formula for. So in this case, we have this building that can be separated into two different building parts. So I'm going to use two different markers, and we're going to locate the length, the width, and the height of both of those building parts, because our formula is length times width times height, which gives us the volume of a rectangular prism. The thing about this composite figure is that when the two parts are together, we don't have just a rectangular prism. We have, when it's combined, it's no longer just a rectangular prism. It's completely different. It has different dimensions and different measurements. So I'm going to take this Sharpie and I'm going to separate really clearly these two figures, the same way it is in the problem. Now we're going to call this first figure here part number 1. And I'm going to locate its length, which is over here. The length. I'm going to locate its width, which is down here, and the height, which is over here. And I'm going to plug them in to my formula down here. So my length is 8, my width is 4, and my height is 10. So we know how to calculate the volume of a prism. I know you guys have done that before, but we want to know the total volume of both these figures. So something that might seem right to do or seem easy to do is just multiply all the numbers together. But I'm going to show you why that can't be done. So I'm going to move my camera down here to show you this three-dimensional version of the same figure from the problem. As you can see from the sheet here, on the first building, the first part, the length is 8, just like I have it up there. The height is 10, and the width is 4. So I'm going to move the camera down over here, and we're going to see that the length spans this entire part, from this side all the way to this side. The height being from all the way from the top to all the way to the bottom, and the width being from this corner all the way to this corner. When we're looking at the volume, we're looking at how much can be filled up into this space. It's capacity. Now, if we look at this other figure here, the dimensions are a little bit different. So even without looking at the measurements, I'm going to move the camera down. You can see this one is much shorter than this piece. And when we look at the numbers, the height of this is 10 meters, and the height over here is 4 meters. The width is 6 meters. The width here is 4 meters. I can't just multiply all these numbers together, because one, the volume is length times width times height. One length times one width times one height. And if I start multiplying all these numbers together, it's not going to give me a correct answer. The height of this part of this rectangular prism is not 4, and the width is not 6. So I can't take numbers from this rectangular prism that's already completed and apply it to this rectangular prism. I'm going to have to figure out each one separately and then add them together to see how much space or how much they can be filled up, their capacity. So I'm going to come back down to our sheet over here. And I'm going to take the blue marker, and we're going to locate the length, the width, and the height of my part number 2 of this figure. So my length is 8. I'm going to fill it in as I locate each part. My width is 6. Oops. There we go. And my height is 4. Now what do we do next? We need to multiply. So 8 times, let me do it with the same marker. 8 times 4 is 32. And 32 times 10 is 320. Now, I found the volume of this first part. That is only the volume of this part of the building. This is all we found, this white building over here. We don't know the volume of this part yet, and I only use those measurements to find this one. And then we have to add it to the volume once we find it of this rectangular prism to get our total. But right now in this part of the video, I want you to pause the video and I want you to jump back to the slide and I want you to answer the first question. The question is, what is volume? Give me the formula and then explain what the formula is measuring. So now I want you to pause the video, go to the slide, answer that question, and then come right back. Okay, so you should have paused the video, answered the first guiding question on the PowerPoint, and now you're back for the next part of the video. So we've already figured out the volume of the first part of this figure. Now I'm going to do the second one. So 8 times 6 is 48, and 48 times 4 is 192 meters cubed. Remember that the unit is very important. It's meters, as we can tell over here. It tells us what the unit is. And then over here, it tells me that it's cubed. Or I should know that it's cubed because I'm multiplying by 3 different dimensions. Now, to find the total volume of this building, I need to add the volume of both individual parts. So my first part is 320. My second part has a volume of 192 meters cubed. And the final total is 512. Woo! We did it. So my total volume is 512. That was when we combined the total volume of the first part, which is 320, and the total volume of the second part, which is 192. And we know that we can't take measurements from one rectangular prism that we separated when trying to figure out the 2 rectangular prisms in this overall figure. We can't take those measurements and apply them to a different rectangular prism. The volume formula is for rectangular prisms, and when these two are together, they are not a rectangular prism. We have to separate them to get those rectangular prisms, and then take the specific measurements of length, width, and height to find the total volume. Then when we add those 2 volumes together, we get the volume of the entire figure. Thank you, everyone. I miss you. Have fun with all this math work that you have to do in your English, and have fun with your free time. And I'm sure it's really interesting learning online. And I miss you guys. Bye. See you soon.